Hi guys, good morning. Can you hear me? Hello. Can you hear me?
Yes.
Yeah.
Yes, sir. Good morning. We can hear you.
Yes, thank you. Thank you. Yes, if anyone unable to hear me, just resign. Unable to hear me, rejoin the session. Rejoin the session. Yes. If anyone unable to hear me, just rejoin. Just rejoin the session. If anyone unable to hear me, rejoin the session. Yeah. Let us start session. So last class, yesterday topic. Yesterday. Yes. See yesterday topic. See yesterday that introduction to software discussed. What is system software and what is application software discussed. Yes, yesterday. Yes, today was first class. Yes, no issue. Yesterday nothing discussed. Just it's only introduction discussed. Just only introduction discussed. Nothing discussed yesterday. Yesterday only started actual classes. See, yesterday started actual class. Okay. Yes. So only basics were discussed. System software, application software. Yes, sir. Still, if you want from the beginning, yes, Monday new batch on 19th, new batch at 9:30 a.m. You can join that batch here. On 19th, new batch available. Yes. Vikas, Spain. Vinamra Vikas. It's available new batch.
Yes, sir.
On 19th.
It's on 19th September.
Yeah, 19th September. Yes. On 19th Monday, coming Monday. Till 3 more days to go. 19th September. At 9:30 a.m. new batch is available. You can attend that batch beginning if you want. Suppose today
Okay.
it's okay because today just yesterday only class started. This is yesterday only started. Just only one topic missed. Yes, I can use the recording. You can watch the recording. Yesterday's topic you can watch the recording. Yesterday topic
Okay, sure.
just only basics were discussed. You can watch that recording. Still, if you want to come from the beginning on 19th, you can attend from 19th. Okay, we'll share the link. 19th batch, you can attend from the beginning, or else you can continue with this batch. Okay, so yesterday topic, I can share the link. Yesterday topic, I can share the recording. Just you go through that recording, you can continue. Okay, yes. Yes,
Okay,
so
sir,
yeah,
please share the yesterday class link.
yeah, definitely. I'll share it. Okay, yeah. So introduction to software, system software, application software. This topic discussed yesterday. Next, about OS discussed, how OS is working, about OS discussed here. Next, application software, front end, back end. This topic discussed in front end, language and packages. Okay, see software. Software is a collection of programs. In this, there is a system software, application software. Java is application software. Java is application software. So that's the reason move to application software. Yes, in application software, there is a front end, back end. Front end, back end. Java is a front end. So that's the reason move to front end. In front end language and packages. Java is a language. Then move to languages. Okay, yes, language, low level, high level language. See, up to this topic we discussed yesterday. Low level language, high level languages. Okay, so up to this topic completed. Low level, high level. Okay, low level language, it's in the form of binary codes. Okay, see here low level language. Yes, low level language. Yes, low level language, low level language, low level language. Low level language, it's a system understandable language. Yes, in software, there are two categories of languages. In software, two categories of languages, low level language, high level language. First one, low level language. Yes, it is a system understandable language. It is a system understandable language. It's a system understandable language. System understandable language. Yes, it is in the form of binary code. It is in the form of binary code. Binary code like a zeros one. This binary code. Zeros ones. Yes, it is called as machine language. It is called as machine language. It's a machine language. It is called as machine language. It is called as machine language. It is called as machine language. It's a system understandable language. Next, a high level language. Yes, high level language. High level language. It's a user understandable language. High level language. Yes, it's a user understandable. Okay, see, low level language is system understandable. System understandable. High level language, user understandable. User understandable. High level language, user understandable. Yes, it is like a English language. It is like English language. It is like English. It's like English language. It's like English language. It's like English language. It is like English language. Okay. Yes, high level language examples. C language. Yes, C++, Java, all the high level language. Python, HTML. Yes, next. .NET, C#. These all the high level languages. Like this many things high level languages. Okay. C program, C++, Java, Python, all this looks like a English language. See, C program. For example, C program. Yeah, this is some C program. See, this looking like English language, right? So this is called as high level language. High level language. It's looking like English language. Looking like English language. Next, one more example, Java program. Java program. Suppose this is some Java program. See, Java program also looking like English language, right? Like English language. English language. So they are high level language. C program, C++, Java, all their high level languages. Okay. Yes, this high level language. So this high level language has to convert into binary codes. Okay. Yes, high level language to binary codes. High level language to binary codes. Okay. So every high level language program has to convert into binary codes. C program convert into binary code, then executing. C++ program has to convert into binary code, then executing. Java converting to binary code, then executing. Python converting to binary code, then executing. So every high level language program, high level language to binary code. Who will convert it here? Which one will convert from high level language to binary code? Yes, which one will convert from high level language to binary code? Which one will convert from high level language to binary code? For this, either compiler or interpreter. Either compiler or interpreter. Compiler or interpreter. Okay. Yes, compiler. Yes, compiler or interpreter. Compiler or interpreter. Compiler or interpreter. Or interpreter. Okay. Compiler or interpreter converts from high level language to binary codes. High level language to binary codes. High level language to binary codes. See, either compiler or interpreter. Compiler or interpreter converts from high level language to binary code. Yes, compiler or interpreter. Compiler or interpreter converts from high level language to binary codes. So compiler, interpreter both are converting from high level language to binary codes. That means high level language means your C program or Java program. The Java program converting into binary code means system understandable language. Okay, Java program converting into yes system understandable language. This program high level language converting into binary codes. After converting to binary code executes. So compiler, interpreter. So compiler, interpreter converts, both converts from high level language to binary code. What's the difference? So what's the difference between compiler, interpreter? Yes, today topic is about interpreter versus compiler. Today topic is interpreter. Yes, interpreter versus compiler. Yes, interpreter versus compiler. What's the difference between this? Interpreter versus compiler. Yes, how interpreter working, how compiler is working. Let us see. Interpreter and compiler. Okay. So first about interpreter. Yes, interpreter. For this interpreter, I'm taking some Python. Python scripting. Python scripting. Python scripting. Python is a interpreter based language. Yes. Avinash Singh. Only these 2 days you have to register. So once link changed, then not necessary. So next once link changed. Okay, not necessary. That link go to meeting. Next, whenever we go to meeting comes, need not to fill the details every time. Every time is not necessary. Okay. Yes, will be changing in 2 days. Okay. So once all registrations are completed, once all the payments completed, yes, we'll change the link. Yes, mostly Saturday or Friday. Yes, tomorrow or day after tomorrow going to change link. So once link changed, yes, not necessary. We'll inform you. You need link changes. Okay. Yeah. Okay, fine. First, let us see about interpreter. Yes, about the interpreter. Say how interpreter is working. For interpreter, best example, Python. Python is a interpreter based language. Python is a interpreter based language. Yes, let us see some Python example. Python program. See, for Python application development, we'll be using this PyCharm community. Okay. Yes, in our office, we are using the PyCharm community. So PyCharm IDE. But now it's not necessary. Very simple program. We are going to discuss very simple program. Simple script. Yes, script to add, subtract, and multiply two numbers. Addition, subtraction, multiplication of two numbers. Very simple script. For this, IDE is not necessary. IDE, integrated development environment. PyCharm IDE, integrated development environment. It's not necessary. This is not necessary. Let us go with Notepad. Let us go with Notepad. D drive. Suppose sample folder. Yes, here I am using Notepad for the Python program development. Python script. D drive sample. D drive sample. Yes, how can you go to D drive sample location to see this? First open command prompt. At the command prompt, go to D drive sample folder. D drive sample. Command CMD, command prompt. It opens command prompt. After opening command prompt, D colon, that will take to D drive. D colon will take to D drive. D drive. Not DER means that shows the contents of D drive. DER. Yes, enter key. That shows the contents of D drive. Yes, contents of D drive. D drive is called DER. Output. Contents of D drive. Contents of D drive. Okay. Now from D drive we should go to sample folder. Sample, it's a folder. Sample is folder. Sample folder. Same thing, character interface, it's a directory. Sample directory. Here dir means is a directory. Sample directory. Directory folder both are same. Directory folder both are same here. Okay. See, in GA calling as folder. In GA it's a folder. In GA it's a folder. It's a folder. In character interface, directory. Yes, directory. Directory. Both are same here. Both are same. Okay. Yes. Both are similar. Both are same. Both are same. Only terminology difference here. Only terminology difference. 1 second. No. Tell me. Yeah, I'm in some class. I'm in some meeting. See, yes, in GUI calling as folder, same thing. In character interface calling as directory. GUI graphical user interface folder, character user interface directory, folder directory both are same. Folder directory both are same here. Only terminology difference. Only terminology. In GUI, simply calling as folder. Sample is a folder. Okay. In character interface directory. Now we should change to sample directory. Changing to sample cd command. Cd means change of directory. Cd sample changed. Yes, I am repeating once again. Exit. Exit. Close the session here. Yes, cmd command prompt. Open a command prompt. Yes, now C drive uses command route. From this location, we should go to D drive. D colon that will take to D drive. Okay, D here that shows the contents. Yes, in this here there is a sample directory. We should go to sample directory. To go to sample directory, cd command change of directory, cd sample changed, cls screen cleared, not dr its contents, sample directory contents, nothing, empty. See this, 0 files, 0 bytes, empty, don't have any file, 0 files, 0 bytes. It's the empty folder, sample directory is empty folder. See, empty folder, it's empty, nothing, it's empty folder, it's empty folder. Now here, no writing Python script. Yes, notepad, test.py. Okay. See, latecomers. Today topic is interpreter versus compiler. See, yesterday we discussed about all these basics. Here, like yes, low-level language, high-level languages. Yes, converting from high-level language to low-level language. Interpreter or compiler converts from high-level language to binding. So topic is interpreter versus compiler. Difference between interpreter and compiler. Interpreter versus compiler. Okay. Yes. First, let us see about interpreter. For interpreter, I'm taking Python. Python is a interpreter-based language. So Python is a interpreter-based language. Okay. So here, see interpreter, how interpreter is working. For this purpose, to explain about this, I am taking Python example. Yes. See, for this D drive, this sample folder here, I'm writing some Python script using Notepad. Just I'm writing some script here. D drive sample folder. Okay. Yes. See. Exit. Yes, D drive sample folder. Yes, command and first go to command prompt. Yes, open command prompt. Now go to D drive, D colon, that will take to D drive here. D here that shows the contents here. Contents of D drive. Yes, all these contents of D drive contents. Okay. Now sample folder directory. Yes, here it's a directory. Directory folder both are same. GUI calling as folder, in character interface calling as directory. See, this is GUI. Here it's a folder. Yes, next this is character interface. It's a directory. That's it. Both are same. Okay, now change to sample directory. For the cd command, change of directory. Cd sample changed. CLS, clear the screen. Now check the contents. Here, yes, nothing, empty. 0 file, 0 bytes. Empty. It's empty folder. Now let us start. Yes, notepad. Test.py. Yes, now Python script. Yes, cannot find test.py file here. Do you want to create? Say yes. Yes, now let us write very simple script here. Yes, a equal to 10 here. Yes, next b is equal to 20. Okay, c equal to a plus b. Yes, print. Yes, print addition is equal to display the c value. Okay, so this addition. Next subtraction, next multiplication, next subtraction. subtraction. So next is about subtraction. Yes, subtraction, subtraction. Next multiplication, next multiplication. Yes, multiplication, subtraction, multiplication. Okay, fine. Okay. So A into B, this is A into B. See here, A equal to 10, A equal to 20 here. Yes, A equal to 10, B equal to 20, A value 10, B value 20, C equal to A plus B means, so addition value is 30. Next A minus B, subtraction, it's a minus 10, minus 10, A into B, 200, multiplication 200, that's it. Save, control yes, save the notepad file, then exit. Now TR check it, see this, s.py, that Python script. Yes, 10:55 AM, 59. So 15th September at 10:55. Right, okay. Now run it. Run it here. Yes, Python. Yes, test.py. Test.py. See, Python is the interpreter. Python interpreter running the test script here. Python interpreter running the test script here. See that? Yes, addition, subtraction, multiplication. So this output addition, subtraction, multiplication, right? Addition, subtraction, multiplication. It's giving, right? See, suppose same thing if it's C program, first of all, you have to compile the C program and checking for errors. In C program, first of all, we should check for the errors. After checking errors, then execution, right? In C program, first of all, we should check for the errors. Errors. If no errors, then executing, right? If no errors, then executing. But in Python, errors checking is not necessary. It won't check for errors. Okay. Yes, 1 second. 1 second. Yeah. So in Python, it won't check for errors, directly executing. Directly executing. It won't check for errors, directly executing. Suppose if any error comes, what happens? Let us see. Yes, in this script, some error. Some error. A is equal to 10, B is equal to 20, C equal to A plus B. Suppose here some comma missing. Comma missing. Suppose here some bracket missing. Okay. Suppose here double quotation missing. There are 3 errors. Totally 3 errors. 3 errors, right? Now run it here. Yes, run it. Running. Yes, that error. Addition here, right? Actually, there are 3 errors, but showing you only one error here. Actually, in complete script, three errors are there. 3 errors, but showing only one error. Yes. So what is happening here? How it's working? Actually, there are 3 errors. 3 errors, but showing you only one error. Then how it's working? Let us see how that interpreter is working. Let us see about interpreter. How that interpreter is working? Yes, how that interpreter is working. So the Python interpreter. So first statement A equal to 10. Next B is equal to 20. C equal to A plus B. Print addition. Okay, next C equal to A minus B. Print is subtraction. Okay, next C equal to A into B. Next print C. Okay, so this is your script like this. So this script is like this. Yes, how that interpreter is working here. See what happens, how it's working here. Interpreter, first of all, checking first line. Interpreter checking first line. Interpreter checking first line. Suppose first line is correct, simply it converts the statement into binary code. Yes, if first line is correct here, it converts the statement into binary code. Okay. Yes, converting to binary code. Yes, interpreter checking for the syntax of the first line. Syntax means like open brackets and close bracket, open double quote, close double quote, that is syntax. Okay. Suppose if it is correct, simply converts into binary code. That binary code given to processor. That binary code given to processor. Binary code given to processor. Yes, then generating output. So interpreter checks the first statement. Interpreter checks the first statement. If first statement is correct, converts into binary code. That binary code given to processor, generating output here. So first line over, checking and execution. Suppose see this. Next statement will be Errors or not. Okay. Yes. Here interpreter never think about next coming statements. Interpreter never think about next coming statements. So next coming statements may be right or wrong. Next coming statements may be right or wrong. It won't think about next coming statements. Yes, if the statement is correct, immediately converts into binary code generating outputs. Okay, 1 second. Let me have some water. See, interpreter checking first line. If it is correct, converts into binary code, then executes. See, next coming statement may be right or wrong. So interpreter never think about next coming statements. Yes, if the statement is correct, immediately converts into binary code generating outputs. Next, checking for next statement. Checking for next, suppose next statement also same thing happens here. Same thing happens here, converts into binary code. Next statement also converts into binary code here. Okay, so next statement also correct. Same thing happens, converts into binary code, generating output, converts into binary, then executing. Okay, yes, 1 second. Yes. So next statement checking, converting to binary code, then executing. So like this line by line, first line checking, if it is correct, converts into binary code, generating output. Second line correct, converts into binary code, generating output. Suppose something wrong here. Something wrong, next statement, something wrong, simply stops. Yes, it won't go to next coming statements. Any error comes, simply stops. Any error comes, simply stops. Any error comes, simply stop. See here. First error. At the first error itself, stop, right? Actually, there are 3 errors. In our script, totally 3 errors. 3 errors. So whenever first error comes, simply stops. Now, let us correct that error here. Yes, that error. 8th line. So this is error. Comma missing. Save. Save and exit. Okay. Now again submit here. Again submit. Yes, it's showing next error. Means it shows only one error. Interpreter shows only one error. It shows only one error here. Now let us correct that mistake also. 12th line error. Yes, my bracket here, bracket missing. This is yes after correction. Now submit again. Yes, next line error. This is error. 70th line means it's showing only one error at a time. Interpreter shows only one error at a time. Interpreter shows only one error at a time. Interpreter shows okay only one error. Save and exit. Okay, yes, now run it, now it's working. Subtraction, yes, addition, subtraction, multiplication. See, here I'm using up arrow key for get the previous comments. Up arrow key to get the previous comment. Up arrow, arrow key, up arrow, down arrow. Yes, it will maintain the history. Command prompt will maintain the history. Up arrow key, up arrow key, up arrow key. We can get the previous comments. Up arrow key. See, every time typing is time taken, so I'm using up arrow key. Up arrow key getting comment, then executing. See, up arrow key getting comment, up arrow key. Notepad. Open that. Yes, this is background right. Yes, next up arrow key. Yes. Okay, right. So this is working of interpreter. How interpreter is working? See, interpreter checks the first line. If it is correct, immediately converts into binary codes and given to processor generating output here. Next statement checking for next statement also correct, converts into binary code and generating outputs. So line by line, it's happening line by line. It executes line by line. Interpreter executes program line by line. First line checking if it is correct, generating output. Next line checking if it is correct, generating output immediately. Suppose something wrong, stops. Something wrong, stops. This is working of interpreter. Okay, right? Next compiler. How compiler working? Yes, how compiler working? Yes, compiler. About compiler. See about compiler. Yes, how compile is working? Let us say about compiler. For the compiler, I'm taking C program. For compiler, I'm taking C program. Some test.c. That's it's working here. How it's working. See here, compiler checks for the first line. Compiler checks the first line. Suppose first line correct. First line correct. Even correct, it won't convert into binary code. No. Even it correct, it won't convert into binary code. Suppose second line also correct. Even correct, it won't convert. It won't convert into binary code. Okay, just checking. So first of all, checking correct. Next checking correct. Next statement something wrong. So simply compiler says that error at some line. Error at some line. After checking for next line also correct. Then checking for next statement. Checking for next statement. Okay. So like this top to bottom, compiler checks the whole program from top to bottom and shows all the errors. Checking from top to bottom and shows all the errors. Okay. See, interpreter shows only one error. Any error comes, interpreter stops. But compiler is not like that here. Compiler checks the whole program from top to bottom. Compiler checks the whole code from top to bottom. It checks whole code from top to bottom, shows all the errors. It checks complete code from top to bottom. Top to bottom shows all the errors. Next, we should correct the errors. Correction of errors. Correction. Suppose, yes, next time after correction you have to recompile. So next time if no errors, then what happens here? Next time if no errors, then what happens here? Publish. Yes. It opens another file. If no errors, compiler checks the whole program from top to bottom. Suppose if no errors, then compiler convert this whole code into binary format. Yes, binary format, zeros, ones, and write to another file. It opens one more file, write to another file, zeros, ones format. Okay, that whole code, converts into binary format, zeros, ones format here. Yes, write to another file. Okay, write to another file. This file is called as exe file, test.exe file. This exe file given to processor finally. So processor taking that exe file, execute, generating output at a time. So at a time executing all the statements here. So compiler checks whole program from top to bottom and shows all the errors. Suppose if no errors, whole code, this whole complete code top to bottom converts into binary format and write to another file. That file is exe file. So compiler checking for all the errors. If no errors, then generating one exe file. That exe file given to processor, finally generating outputs. That's it. So this is working of compiler. Let us see example, C program example for compiler C program. Yes. Turbo C, it's a C language. Turbo C. Here this program, see this is a program. C program to add, subtract and multiply two numbers. Same example here also. Add, subtract, multiply two numbers. Okay. See main function TABC, CLR here to clear the screen. Enter first number, reading first number, second number. C equal to A plus B, addition. C equal to A minus B, subtraction. C equal to A and B, multiplication. C compile, no error, success, no error, run it. Yes, enter first number 10, second number 20. See that. First number 10, second number 20, addition 30, subtraction minus 10, multiplication 200. 30 minus 10, 200. Okay, fine. Suppose there are some errors. What happens here? There are some errors. Suppose here some mistake, semicolon missing, here bracket missing. Suppose here comma missing. Okay, comma missing. Suppose here double quotation missing. Okay, suppose here semicolon missing. Okay, suppose here some bracket missing. Suppose here, okay, semicolon missing. Now file, save it, saved. After saving, compilation. Compile option, compile series errors. There are 10 errors. 10 errors in the program, but it's showing all the errors. 10 errors. Press any key, rate. See the 10 errors. 16th line error. Next 18th line error. See at the bottom. 22nd line error. 27th line error. 29th line error. 31st line error. 36th line error. 38th line error. 42 line error. Right? It's all the errors here. Yes, compiler shows all the errors from top to bottom. Compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Now let us correct mistakes here. Let us correct that mistakes here. Semicolon missing here. Next here bracket missing here. Next, yes, here, okay, here double quotation missing. Here some double quote missing. Okay. Yes. Here semicolon missing. Semicolon missing. Semicolon missing. Yes. Now save again here. Save it. Save it here. Yes. Overwriting. Now compile. Yes. Still some more errors. 3 errors. Still some more errors. 3 errors. 3 errors. So first is 22nd. This error. Here showing error. This error. So here comma missing. Here comma missing. Comma missing here. Error. Next. Yes. Here semicolon missing. Here semicolon missing. Okay. Yes. Now save it. Once modified, we should save it and recompile. Still one more error. Where is that? Yes. This bracket missing. Yes. Now save it. Yes. Run it. Compile. Run it. Success. Yes. Yes. Compile. Yes. Compile. See here. All see compile success. No errors. No errors. Successfully completed. Success. No errors. When you run it, what happens here? 1 second. Behind of, yes, it's a turbo C ID. TC ID. Turbo C ID. In C drive, it's installed. C drive TC bin folder. Inside the bin folder, this file is available. What is name of the program file? Math.cpp. 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 Yes, go to math.cpp. Here, math.cpp. 1 second. There are some already existing. So let me delete that files here, old files. Delete. See math.cpp. Yes, file saved. Yes. See, just now saved here. This is math.cpp. Okay. 11:12 AM. Yes, 15th September. Just now saved. Just now saved. After saving, now compile. Compile program success. Now run it. So when you try to run it, what happens? Run it. See back and see here. Applicate this math.exe file generated just now. Math.exe. See properties .exe. Here this is .exe. Here this is .exe. So math.exe file generated. So what happens after compilation? When you try to run it, first of all, it generates one exe file. It creates one exe file. That exe file executes finally here. It's generating exe file. That exe file executes. See first number 10, second number 20. Okay, first number 10, second number 20. Okay, 1 second. No. No. Yes. So first number, second, that's it here. Addition, subtraction, multiplication, that's it here. So what's happening here? Yes, here creating one exe file. That exe file executing. That's it here. Okay. Yes. Now compiler interpreter. See interpreter checks line by line. Checking line by line, then executing line by line. If first line is correct, convert into binary code, generating outputs. Next line correct, convert into binary code, generating outputs. So it's a line by line executing. Line by line, interpreter executing line by line. Correct? Any error comes, simply stops. Any error comes, stops. Yes, when you come to compiler checks whole program from top to bottom. Compiler it checks whole program from top to bottom. If no errors, generating exe file with binary code. This whole code converted into binary format and write to one exe file. That exe file submitted to processor. So processor taking exe file and executing, generating output at a time. That's it. Now tell me guys, what's the difference you observed between interpreter and compiler. See this. In this space, interpreter expand here. In this space, compiler expand. What's the difference he observed here? See, between these two pages, what's the difference he observes? Tell me what's the main difference he observed here? Interpreter and compiler. Interpreter and compiler. What's the main difference he observed? Tell me guys. Interpreter and compiler. What is the main difference he observed here? What's the main difference? No one observed? See, in first page and second page. In first page, second page explanation. See, just the first page. In first page, interpreter explanation is there. In second page, compiler explanation is there. What's the difference you observed? Tell me, guys. Okay, Swami Konda. Yes, compiler will run entire program. See, just try to observe these two pages. In this page, what's the difference observed here? Just see that page. In this page, one box, right? What is the second box? What is that second box? In this explanation, what is that second box?
Compiler check the all program.
Yes, what is this box? What this box is for what? Yes, this box extra showing, right? Showing some extra box. What is this box? What is that box here? exe file, right? It's exe file. exe file. Here this is exactly difference here. Compiler interpreter main difference exe file. exe file. exe file. Compiler generates exe file. Compiler generates exe file. Interpreter does not generate exe file. This is main difference. So exe file is a difference. Let us see the differences. Let us compare interpreter versus compiler. Yes. Yes, interpreter versus compiler. Yes, interpreter versus compiler. What's the difference? See, interpreter. Yes, how it's working. Interpreter, it checks the code line by line. It checks the code line by line. Right? Interpreter, it checks the code line by line. What is compiler? Whole program at a time. Yes, it checks whole code from top to bottom, from top to bottom. So this is first difference. See, interpreter checks the code. Interpreter checks the code line by line. Interpreter checks the code line by line. Compiler, it checks whole code from top to bottom. Right? Next, when come to output, interpreter generates output line by line. Generates output line by line. Line by line output, line by line. Compiler at a time output. It generates output at a time. Yes, it generates outputs at a time. Output at a time. At a time outputs. You see, interpreter generates output line by line. Compiler generates output at a time. So this is line by line output here. So compiler at a time outputs. Next, see in interpreter, any error comes simply stops. Any error comes simply stops means it shows only one error. It shows only one error. Only one error. It shows only one error. It shows only one error. Yes, compiler. It shows all the errors from top to bottom. It shows all the errors from yes top to bottom, from top to bottom. It shows all the errors from top to bottom. Okay. Yes, interpreter. It shows only one error. Interpreter shows only one error. Compiler, it shows all the errors from top to bottom. Okay, right? Yes. Next, main difference. Main difference here. Interpreter, it does not generate exe file. It does not generate exe file. It does not generate exe file. Compiler, it generates exe file. It generates exe file. It generates exe file. So this is main difference here. Okay. Interpreter, it does not generate exe file. It does not generate exe file. Compiler, it generates exe file. See, interpreter checks the code line by line. Compiler checks the whole code from top to bottom, checking complete codes. Interpreter only one line checking at a time here. Okay. Yes. Next, output also line by line. But compiler, it generates output at a time because the exe file executing. Finally generating one exe file, that exe executing at a time. Right? So at a time output here. Next, interpreter, it shows only one error. It shows only one error. But compiler shows all the errors from top, but all errors from top to bottom, all errors. Interpreter, it does not generate exe file. Yes, compiler generates exe file. It does not generate exe file. Compiler generates exe file. Okay, next. Yes, next, one more difference. See, interpreter, what happens in Python? The script executed directly. Yes, it's a source code. It's a source code. The source code executing directly. This is source code, right? This code is called a source. Your program is a source code. It's a source code. That source code executing directly. See, suppose this is C program. It's a C program source code. It's a C source code. C program source code. So this is Java program source code. So we are writing programs, right? That programs are source code called as source code. Okay. So what happens? Interpreter executes source code directly. See, interpreter executing source code directly. Yes, no exe file, right? See that? Only test.py. Only the source file. Don't have exe file. Don't have exe file. It executes source code directly. Okay. When come to C program, what happens here? Yes, it will generate. It will generate one exe file. That math.exe file generated. That exe file executes. Okay. So compiler means it executes exe file. Yes, interpreter, it executes source code directly. It executes source code directly. It executes source code directly. Yes, it executes. Interpreter, it executes source code directly. Compiler, it executes exe file. It executes exe file. Yeah, these are different. Fourth and fifth point is a main difference here. These 2 points are important. Okay. Yes, interpreter does not generate exe file. Compiler generates exe file. Yes, interpreter executes source code directly. Compiler, it executes exe file. It executes exe file. So interpreter generating exe file and executes that exe file. Compiler does not generate exe file, so source code executes. That's it here. Okay. See, interpreter based languages are called scripting languages. Here these are called as scripting languages. Scripting languages. These are called as scripting languages. Okay. So these are called as scripting languages. Interpreter based. These are called as scripting languages. Yes, compiler based. These are called as programming languages. They called as programming language. So these are called as scripting languages. Next, these are called as programming languages. Interpreter based is scripting language. Yes, compiler based language are called as programming language. Scripting language examples. Let us see some examples here. Examples. Python is a scripting language. Okay. HTML is a scripting language. JavaScript is a scripting language. Okay. Next, PHP is a scripting language. Linux is shell scripting language. Next, Perl scripting language. They are scripting languages. Okay. This scripting language don't have exe file. No exe. Python no exe. HTML hypertext markup language. HTML hypertext markup language. It's a browser understandable language. Yes, HTML is a browser understandable language. Browser is the interpreter for this. See, for HTML and JavaScript, browser is an interpreter. These two are interpreter, browser understandable language. Okay. Next, PHP, its own interpreter, shell, one interpreter, Perl, and all this having its own interpreters. These are interpreter based languages. Okay. Right. Yes, compiler based examples. Compiler based examples, C language, C++, and .NET C#. These are the compiler based languages. So these are interpreter based language examples. These are compiler based languages. Okay. See. So finally here, come to some conclusion. See, interpreter based language don't have exe file. Simple conclusion. So interpreter, yes, interpreter based language don't have exe file. Simply conclusion. Interpreter based language don't have exe file. Yes, compile based, here everything is exe file. Everything is an exe file. So first exe file generating and executes. So every time exe file in here, everything is an exe file. So here everything is an exe file. Exe generates and executes. That's it here. So interpreter based language don't have exe file. Finally, conclusion here on interpreter. See, interpreter compiler, interpreter line by line, compile is whole program at a time. Yes, interpreter output or line by line, compiler at a time output here. It shows interpreter shows only one error, but compile shows all the errors from top to bottom. Next, interpreter does not generate exe file. Compiler generates exe file. Okay, it executes source codes. Yes, compiler executes exe file. So these are scripting languages. These are programming language examples. These things here. Yes, interpreter based language don't have exe file. Simply, finally, conclusion here. Interpreter based language don't have exe file. Only compiler based language exe files. Okay, fine. Fine. So this is difference between interpreter and compiler. That's like a fine. See, these are interpreter based language examples here, compiler based examples. Now what is Java? Yes. Now we should discuss about Java. Java. Yes, about Java. Java. Is it interpreter based or compiler based? Is it interpreter based or compiler based? Okay. Yes. Yes, Java. Java. Yes. Is it compiler based? Compiler based or interpreter based? Java. Is it compiler based or interpreter based? Yes, anyone? Yes, anyone idea about this? Yes, Java, is it compiler based or interpreter based? Java, compiler, interpreter. Java, compiler, interpreter. Yes, most of the guys saying that compiler.
Compiler.
Rahul saying that compiler. Nikita saying that compiler. Vinamra saying that compiler. Shivaji saying that compiler. Yes. Yes, Swami Konda. Both. Nikita compiler. Avinash interpreter based. Avinash Singh interpreter based. Rutuja interpreter based. Kalyan Chakravarti compiler based. Sunarvita interpreter based. Sunarvita. Yes. Something different name. Good. Yes. Okay. So here compiler based, interpreter based, compiler based, interpreter based. Yes, someone saying that both also. Let us see. Let me explain. Let me explain. First, I'll explain about Java. You decide it. How Java working? I'll explain it here. You decide it. Is it compiler or interpreter? You have to decide it here. Okay, I will explain it. How Java working? Let me explain. Once you complete it, now you decide it. You can decide it here. Yes, let us start. See, except Java in other languages. Except Java in other languages, what happens here? First, source code converts into binary code. Source code. This is source code. This source code. This source code converts into binary code. Zeros ones format. Source code to binary code. Source code converts into binary code. Source code converts into binary code. Source code converts into binary code. Then binary code given to processor. So processor generating code. This is what is happening with other languages. Source code to binary code by the compiler or interpreter. If it is scripting language, then interpreter. Programming language, then compiler. Source code to binary code by the compiler or interpreter. source code to binary code by the compiler or interpreter. That's a case of other language. Now come to Java. Yes, in Java what happens? In Java what happens here? So first of all, source code converts into bytecode. Bytecode. That bytecode converts into binary code. Binary code. Binary code. Bytecode converts into binary code. That binary code given to processor. Processor generating outputs. Yes, in Java, two steps. Source code converts into bytecode to binary code. It happens in two steps. In other language, only one step. Source to binary code, only one step. But when come to Java, source code converts into bytecode, that bytecode converts into binary code. It happens in two steps here. See bytecode. So why bytecode introduced in Java? Yes, bytecode introduced in Java to make the Java as independent platform. Okay. Yes. See, bytecode was introduced. Yes, to make Java program as independent platform, independent of platform, independent platform. So bytecode was introduced to make Java programmers independent platform. Bytecode was introduced. This bytecode, why bytecode introduced in Java here? Yes, to make Java as independent platform. So bytecode, source code to bytecode to binary code. Then binary code given to processor, then generating outputs. Yes, let us see Java example also. Java program. Suppose tell star deleting all the files, deleted. Yes, CLS here. No files. Let us take Java program, simple Java program. Notepad test.java. Yes, creating new file. Yes, public class test class, public class test, starting test class, ending test class. Next here public static void main, public static void main, string square bracket dots. Okay, starting main method here system dot, yes, out dot println here it's a hello world, closing main methods. Okay, save it. Very simple program, save and exit here, save and exit. No compilation. See, once again here, see output test.java file developed 11:32 AM just now, 15:09. So 15:09 means September 15th, 11:32 AM. Test.java file created. Now let us compile it. We should compile Java sim Java compiler, test.java compiled. After compilation, result is dot class file. Tested dot class. Yet this dot class contains bytecode. Tested.java is a source code. It's a source code. Yes, test.java. Yeah, this is called a source. This is called a source code. It's a source code. It's a source code file. Yes, that source code file given to Java compiler. Source code file given to Java compiler. Java sim Java compiler taken test.java and generated dot class file, tested dot class file generated at 11:33 AM, right? So this dot class file is completely bytecode. This dot class file contains bytecode. See what happens here. Yes. So first, yes, source code. Yes. Test.java program. Test.java. It's a source code, right? It's a source code. It's a source code file that will be given to Java compiler, Java C compiler. Java compiler taking the source code here. Yes, checking for all errors. If no errors, generating dot class file. Tested dot class file. Test dot class file. Yes, it's a bytecode. Okay. So test.java source code is compiling, generating dot class file. It's a bytecode, right? Yeah, this dot class file. Next, what happens? See, test.java is source code. Okay, taken by the Java compiler, generating dot class bytecode, right? Source code to bytecode, source code to bytecode. So source code to bytecodes, compiler checking for all the errors, compiler checking for all the errors. If no errors, generating bytecode file. Yes, after what is next step? Now running Java program, Java test, Java test. Yes, enter key. Yes, is dot class file executing. Yes, to run that, don't use dot class. Dot class is not necessary. Suppose if using dot class, it shows error. Dot class error message. Don't use dot class here. So Java test, just test, enter key, that's here. So what are the steps in this here? What are the steps followed here? So first, notepad. Using notepad, program developed. It's a source code developed. Okay. So next what? Compilation. Source code converting into, yes, converting into dot class file. Java C, sorry. Compilation Java C. Test.java compiled. Compiled, generated one dot class file. Generate dot class file. Now this dot class file executed Java test. Yes, executed. Hello world output. Hello world output, right? Now what's happening? What is this? Java C means it's a Java compiler. Java C means Java compiler. Java C means Java compiler. Here Java means what? Interpreter. It's a Java interpreter. This is Java compiler. Java C means Java compiler. Java compiler. Java means it's a Java interpreter. Java compiler. Java interpreter. Java compiler, Java interpreter. Now what's happened here? Test.java given to Java compiler. See, test.java given to Java compiler. Generate one dot class file. That dot class file given to Java interpreter. Java interpreter. Java interpreter. Interpreter. Okay. Interpreter, right? Interpreter. So interpreter, right? Java interpreter. The Java interpreter generating, yes, converts that code into binary codes. Okay. Java interpreter converts that code into binary codes. Binary codes. Binary codes. Okay. So here source code given to Java compiler that converts into bytecode file. That bytecode given to Java interpreter. Java interpreter taking bytecodes, converting into binary codes. That binary codes given to processor, finally generating outputs. Finally generating output like this. Finally generating output. Finally getting output, right? So what is happening here? First, this part. See in this part, source code to bytecode by the compiler. Source code to bytecode. This is by the Java compiler. This is by Java compiler. Java compiler. Okay. Next, bytecode to binary code. This part. Bytecode to binary code. Bytecode to binary codes by the Java interpreter. Java interpreter. Java interpreter. Okay. Source code to bytecode by the Java compiler. Source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. So what is happening here? Yes, in Java. So Java errors checking. Error checking by the compiler. Java errors checking by the compiler. Yes, if no errors, then it generates dot class. It generates dot class file. Okay, errors checking by the compiler. Okay, right. Next, Java program dot class file. The dot class file executing by the, yes, executing by the interpreter, right? Executing by the interpreter. Okay, right? So what is happening here? Source code to bytecode by the Java compiler, bytecode to binary code. The program execution by the interpreter, errors checking by the compiler, program execution by the interpreter. So there are two things involving Java compiler as well interpreter. Okay, now tell me, Java depends on what? Java, is it compiler based or interpreter based? Now come to some conclusion. What's the answer here? Tell me, guys. Java depends on what? Is it compiler based or interpreter based? Yes, answer is both. Answer is both. Answer is both. Answer is both. Okay. Yes, Java. Java is a compiler as well as interpreter based here. Java. Yes, Java. Java depends. Java depends on. Yes, depends on both. Java depends on both. Both compiler as well interpreter. That's it. Okay, Java depends on both compiler as well interpreter. Right? Yes, here some question for you guys. Some question. Yes, can we create exe file in Java? Yes or yes, is there any exe file concept in Java? Is there an exe file concept in Java? Yes. Tell me guys. Yes, from our last explanation, what you observed here? Yes, have you observed any exe file in our last steps? Have you observed any exe file? See, just .java .class .class is not exe file. Exe file is different. .class is different here. .class is not exe file. No exe file concepts. Can we create exe file in Java? No. Yes. No. Yes. Java don't have exe file concept here. See, Java. Yes, don't have. Java don't have exe file concepts. Java don't have exe file concepts. Okay. See, in Java everything is dot. In Java, yes, everything Java and everything is a dot class file. Everything is dot class file. Java everything is a dot class file. In Java everything is a dot class file. See, dot class file is not an exe file. Dot class is not an exe file. Okay, dot class is not an exe file. What is exe file? See, exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file, and it is a system understandable language. It is a system understandable language. Yes, system understandable language. It's a system understandable language. Okay. Yes. Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. What is dot class file? Dot class file is a bytecode file. What is bytecode? We'll discuss in Java programming. Once Java programming started, we'll discuss about bytecode. Once Java programming started, I'll explain about bytecode. Okay. So dot class file is a bytecode file. Dot class is a bytecode file. Yes, and it's a JVM understandable language, and it is a JVM understandable yes, understandable language. JVM understandable language. Okay. See, dot class file is a bytecode file. Dot class file is a bytecode file and say JVM understandable language. Next, one more difference here. Exe file is an OS dependent. Exe file is an OS dependent. Yes, dot class file is an independent file. Dot class file is an independent of OS here. Independent. Yes, independent of OS. Yeah, this topic tomorrow discuss. Tomorrow about Java features. Yes, up to this introduction completed. Even Java introduction also done. All the basics completed. Yes, introduction also completed. Okay. Yes, basics complete, introduction complete, Java introduction complete here. Next, what are Java features here? The features. No, Java compiler won't generate exe file. Java compile is a special case. Java Havina Singh, Java compile is special case. Java compiler generating dot class file. Dot class file is not exe file. Java compile is a special case. Java compiler generates dot class file. Dot class is not exe file. Okay. Yes, exe file is OS dependent. Dot class file, yes, independent of OS. Yes, what is exactly exe file? What is dot class file? Tomorrow we'll discuss. What is exactly exe file? Exe file contains what? Dot class file contains what? This topic tomorrow we'll discuss. Okay. Yes, tomorrow topic is about, yes, Java features. See, today topic. This is today topic. Interpreter versus compare the differences. Today topic. This is today topic. Java depends on both compiler as well interpreter. Java errors checking by the compiler. If an error generating dot class file. Dot class file is a bytecode for same what we discussed till now. That's all that explanation here. Okay, source code to bytecode, bytecode to binary code. Processor finally generating output. Source code to bytecode by Java compiler. Bytecode to binary code by the interpreter. Java depending on both the compiler as well as interpreter. Java runtime is interpreter based. Okay. Can we create exe file in Java? No, we can't create. There is no concept of exe files in Java. So in Java, everything is a dot class file. See, dot class file is not an exe file. See, exe file is a binary code file and is a processor understandable language. Dot class file is a bytecode file and it's a JVM understandable language. Exe file is an OS dependent. Dot class file is independent of OS. Next, one more thing here. One more thing. See, any language. Yes, any language. See, any language. Runtime. Runtime means program execution. Any language runtime means execution by the interpreter. Any language runtime by the interpreter. Yes, interpreter. Yes, don't have exe file. Don't have exe file. Yes, Java program runtime. Okay. Yes, what is JVM understandable? We'll discuss tomorrow topic. We'll discuss that. Yes, about the JVM. Yes, how JVM working, how Java made us independent of that is tomorrow topic. Yes, Rahul, it's it tomorrow. Your doubt is tomorrow topic. Okay. Yes, any language runtime means execution by the interpreter don't have exe file. Now Java program execution by which one? Is it compiler or interpreter here? Java program execution by which one? Is it compiler or interpreter? Here Java compiler is different from other compilers. Java compiler is different from other compilers. Java compiler generating dot class file, other compiler generating dot exe file. See, program execution just now, 1 second, just already explained, right? See this. In Java, errors checking by the compiler. If no errors, it generates dot class file. But Java program dot class file execution by the interpreter. Errors checking by the compiler. Okay, but execution by what? Execution by which one? Interpreter. Program execution by the interpreter. Error checking part is compiler, but runtime execution by the interpreter. Yes, you understand here? Yes, error checking by the compiler. At the time of error checking, compiler involves. Runtime interpreter involves. So two things involving error checking and execution. Error checking by the compiler, execution by the interpreter. To that case, two things involving, but only execution at runtime. Runtime is interpreter. Okay, since Java program, yes, execution by the interpreter. Okay, since Java program execution by the interpreter, yes, don't have exe file. Don't have exe file. One more point about this. Don't have exe file. Since Java program execution by the interpreter, Java runtime is interpreter. See, any language program execution by the interpreter don't have exe file. See, Python, yes, all scripting language executing by the interpreter, so no exe file. Even Java programmers execution by the interpreter. Java programmers execution by the interpreter. Since Java program execution by the interpreter don't have exe file, that's it here. Don't have exe file. That's it. I think understands. So this is about introduction to Java. Introduction to Java. So next about Java features. Java features. Once is our document. This is today's class. A difference between interpreter compared to today's class. Very clearly prepared in document here. Very clearly prepared. Just follow the document here. Follow the document here. Okay. Next tomorrow topic. Yes, about Java features. Yeah, that's all for today. That's all. Right? Yes. Any doubts still? Yes, guys. Any doubts? Yes. Yes, in your WhatsApp group already sharing. Yes, daily class documents under this recording sharing. Next, one more drive access for some students. For some students, already drive access also given. For drive access, still anyone to share your details? This is my WhatsApp number. Take it and share your details. 8179189123 here. Yes, your name. Your name. Yes, next. Your name. Yes, next WhatsApp course you are attending here. Course. Okay. Next time on Gmail. Okay. 1 second. See, Abhinash. Yesterday already I spoke to you. So whenever full Java started, I'll inform you. See, this after at the middle of the core Java will be starting full stack. That time I will inform you. See, after core Java we'll going for full stack, right? At the middle of the core Java will start full stack. That time I'll inform you. Don't worry. Okay, Mr. Avinash. Don't worry. Just be in touch with me. I'll inform you. Okay, Avinash, you guys don't worry. I'll inform you. Yes, still anyone share your details, please share this. This is my WhatsApp number. Share here. Yeah, this is my WhatsApp number. Okay, share your details and add to group. Yes, already communication is going on. Yes. Yes, already for some students drive access given. Yesterday's class link shared already. See, yesterday in group already shared, I think. This one, session 3, 14 September, shared. It's shared. Okay. Yes, in group shared. Yes, for some student drive access also given. Yes, for all paid students. Yes, almost everyone paid except 1 or 2 guys. Yes, 12 members I think paid in your batch. For them, all the documents, recordings, all are shared. Okay. Yes, even in driver, yes, in group also I'm sharing. Just to follow this group message now. Once you get the drive access, you can go to the drive here. Open drive, you can see all. In drive, you can see everything. Okay. Yes, go to Google Drive and check it. You can see all. Okay. Yes, if anyone paid here, go to your Google Drive, check it. Okay. Yes, yeah. So that's all for today. Yeah, Rutuja, just let me check with the online team. I'll take from the online team. I'll take your Gmail ID from online team. I'll take your Gmail ID from online team. I'll share with you. Don't worry. Yes, I will talk to online team. I'll take from the online team. I'll share with you. Okay. Yeah. So that's all. Yes. Thank you guys. See you tomorrow. Yes. Same link tomorrow also. Thank you. See you tomorrow.